All right, guys, let's go ahead and take a quick look at some of the um, major neurotransmitters as requested. Today is December the 14th, 2021. It's about 2:30 in the afternoon. And thank you for coming in. Thank you again for those questions. And let's see if we can get it done, right? I wanted to begin by doing a quick sort of a review type of thing and basic stuff for neurotransmitter. And then after that, we'll go and discuss some of them. And some of the most important ones, the ones that we see commonly and have a great impact on every system in our body, right? We're also going to take a look at these neurotransmitters in a very shortened way, right? In no way this is intended to explain neurotransmitters as they should be. We're just going to make them really condensed, really short. And this is, neurotransmitters, not 101, but neurotransmitters 0.0001, just so you get a general idea, right? So with that being said, we'll talk about some of the things that happen and they do and so on and so forth. Number one is that they have control over a lot of processes and they help facilitate and make happen different processes. Our nervous system controls the body organs, psychological functions, physical functionality, and these nerve cells, also known as neurons, and their neurotransmitters play a very important role in this particular system, right? And controlling a whole bunch of processes through it. These nerve cells will fire nerve impulses, right? But they do this by releasing neurotransmitters, which are these chemicals that carry signals to other cells. And then again, I want you to pay close attention to this. Let's remember that we discussed in class that if we have a point A and a point B, and we throw a wire between these 2 points and we enter electricity here, electricity will transmit to the wire and get to point B from point A. Okay, that's a basic knowledge stuff. But if I come in and I make this wire incomplete, in other words, if I cut it in the middle, then we don't have any way to get electricity from point A to point B. That's where neurotransmitters come in. If we were to place a bucket over here and fill this bucket with a solution, then electricity will go down the wire, right? Pass through a solution and continue to the other end of the wire, right? The less neurotransmitters you have, the faultier the electricity, or the more difficulty this electricity is going to have going through. And the higher this neurotransmitter is in the bucket, the more electricity and the more powerful the signal that you're going to get through that bucket of solution, right? And that's basically very roughly explained what a neurotransmitter does, right? However, neurotransmitter is just way more than that. They relay this message, in other words, letting the electricity go through by traveling between cells and attaching to specific receptors on target cells, right? Each neurotransmitter attaches to different receptor. For example, dopamine will attach to dopamine receptors, right? And when they attach to dopamine receptors, they will trigger an action in this target cell, point B, right? When they attach to point B and electricity goes through, point B goes like, oh, and does an action. Okay, now they have different types of actions. Some of these neurotransmitters will be excitatory, others inhibitory, and yet a third category will be modulatory. They're kind of self-explanatory, right? Excitatory neurotransmitters encourage that target cell or point B to take action. In other words, point B, anytime it feels that neurotransmitter, reacts and does something about it. In the case of the inhibitory neurotransmitter, they decrease the chances of that target cell, in other words, point B, to take action, right? And in some cases, these neurotransmitters have a relaxation-like effect. In other words, when point B comes into contact with an inhibitory neurotransmitter, then point B goes like, okay. And it may not do something about it, as it will be the case of an excitatory one, right? Now, in the case of modulatory neurotransmitters, they can send messages to many neurons at the same time. And they also communicate with other neurotransmitters. This is the calm guy at the office. Okay, guys, let's not go ahead and go crazy. Let's go ahead and talk to each other and let's keep it calm and collected and well functioning, right? So you got the guy that's going to be excitatory, the guy that's going to be inhibitory, and the guy that's going to keep the peace, right? And that will be your modulatory neurotransmitter, roughly said. Okay, so let's move on to the first one. The first one is going to be acetylcholine. Acetylcholine triggers muscle contractions, right? And stimulates some hormones. It also controls heartbeat, right? It also plays a very important role in brain function and memory. And for you guys out there in psych, in any of my psych classes, you're going to immediately remember that memory is related to a particular disease process that I'm highlighting right now in your screen, right? Now you see that connection right there? This is pretty simple. Remember, dementia has got to do with memory. Alzheimer's is a type of dementia where you lose the memory, whereas the other part of this is attention, which is more related to delirium, right? So in the case of acetylcholine, it plays a very important role in brain function and memory. Therefore, lower levels of acetylcholine will be linked to Alzheimer's, also known as dementia, right? So if you have low levels of acetylcholine, your memory will suffer, and therefore we will be having a problem that's related to dementias, Alzheimer's, and so on and so forth. However, when this acetylcholine goes high, then it can cause muscle contraction, and if you get a level that's high enough, it may lead to seizures, right? So low level of acetylcholine, Alzheimer's, high level of acetylcholine, seizures. With that being said, let's move on to dopamine. Here is a big guy. Dopamine is important for memory, but it is also important for learning, behavior, and motor coordination, right? Things that you can coordinate to do. Dopamine is known also as the pleasure or reward neurotransmitter. And I want you to remember this, dopamine, pleasure, right? So the brain releases dopamine during pleasurable activities. Therefore, say one example of it is sex or smoking or drugs or alcohol or anything else that you really like, eating sugary stuff, right? And your brain, every time you do something that's pleasurable, releases that dopamine, makes you want to do it again, right? Let's have a second round. And that is because you have that dopamine factor in this whole equation, right? However, dopamine is also responsible for muscle movement. A dopamine deficiency makes you uncoordinated in your movement, right? For example, as it is the case of Parkinson's disease, when you got the tremors, the shuffling gait, the bradykinesia, where you get really slow, right? So dopamine goes high when you're doing something pleasurable. If you're going too high, you may end up in schizophrenia. If you go too down, too low of this particular neurotransmitter, you will end up in Parkinson's disease, okay? And moving on, let's take a look at endorphins, those all almighty endorphins that everyone's talking about, right? Or the health gurus out there are talking about these endorphins, right? Now, endorphins inhibit pain. These guys are our natural pain relievers that we already have in our very own reserve or pain relievers, right? Not only do they inhibit pain signals, but they also energize you. Makes you euphoric, right? Makes you elated and euphoric after you, for example, exercise. And that's one of those things that they tell you, one of the best known ways to boost the level of endorphins is to exercise. You exercise and then you get euphoric, you get energized, right? You would think that if you exercise, you get tired, but rather what happens is that you get energized and euphoric and, so on and so forth, right? This is what we usually have heard in the past referred to as runner's high, okay? Which is nothing but a flow of endorphins, right? And then again, a deficiency in endorphins is going to be fibromyalgia. But think about this critically, guys. I want you to establish the pattern over here. Endorphins inhibit pain and make you energized. Too high, and you're not going to have any pain, and you're going to have euphoria. You're going to be energetic. Too low, and you're not going to be energetic, and you will have pain. Hence, the fibromyalgia, right? We go up and we go down, and these things are going to move along with it. And then we move on to epinephrine. Epinephrine is a special one. It's a big guy, right? Epinephrine is also known as adrenaline. So it can be referred to as epinephrine or adrenaline, right? And this is a big guy. This is the guy that is primarily involved in the body's fight or flight response. This is both a hormone and neurotransmitter. But when you are stressed or you're scared, your body may release epinephrine, right? And that epinephrine will increase the heart rate, will increase your breathing, will give your muscles a jolt of energy, right? And it will also make your brain make quicker decisions in the face of danger. So, for example, let's go ahead and give you an example so you can relate to epinephrine. You are walking down the African savannah, admiring the scenery, and all of a sudden you turn the corner. I don't know why you would have a corner in the middle of the African savannah, but anyways, you turn a corner and you find a lion looking at you, a very hungry lion. And he's looking at you like a delicious piece of McDonald's, right? And all of a sudden you have two decisions. Either I fight this lion or I'm gonna run for my life. In other words, fight or flight. Well, epinephrine will kick in, and that epinephrine will increase your heart rate so you can move that blood about in your body. Will make you breathe faster, right? So you can oxygenate all that tissue, right? And will give those muscles a jolt of energy so you can either fight that lion or escape, okay? So this is epinephrine for you. However, here's the thing though. Epinephrine can also be used, perhaps because of the response it gets in your body, it can also be used to treat life-threatening conditions, right? Such as anaphylaxis, which is a severe allergic reaction, asthma attacks, cardiac arrest, very big in cardiac arrest, and even severe infections, right? The ability that this particular compound has to constrict your blood vessels can decrease swelling, right? If I constrict, I decrease the swelling, and that results from allergic reactions, asthma attacks, and the sorts. And in addition to that, epinephrine will help the heart contract again. So if you're in cardiac arrest, we'll give you epinephrine, a little bit of CPR, and poof, we may get you contracting back again, right? Now, epinephrine can be useful in all of these situations. However, a lot of chronic stress may cause the body to release too much of it. And then over time, you're going to have chronic vasoconstriction, right? Or constriction of the blood vessels over time. And that is bad for you. So while epinephrine is really good to get you out of a situation, if you're facing a lion in the savannah, it may be a problem over long periods of time, right? And it will lead to cardiac problems, high blood pressure, diabetes, so on and so forth. Right? Epinephrine is good in the short term, not necessarily in the long term, right? It is involved in the fight or flight. It vasoconstricts, and therefore it helps you fight or flight or fight off infections and anaphylaxis and so on and so forth. Okay. Now, the next guy is going to be norepinephrine. Norepinephrine is the most prevalent neurotransmitter in the nervous system, and it plays a role in attention, not memory, but attention, learning, and then memory. But I want you to think of this: attention, which is not memory, attention, learning, and also memory, right? But I want you to include that attention now in the pocket, right, with the norepinephrine. It will also have some influence over sleep and wakefulness, and very important, mood regulation. Excess of norepinephrine has been implicated in anxiety disorder, right? You elevate norepinephrine, you're going to have problems with attention, memory, and mood regulation. In other words, you're going to have anxiety, right? However, deficits of it will include what? Well, quite the contrary: memory loss, social withdrawal, and depression, right? Instead of being anxious and looking everywhere, you're just going to be depressed, right? It's completely the contrary. Now, what happens in norepinephrine is that some antidepressants that are given for depression, for example, right? If you're low in norepinephrine, right? Then again, let me highlight it so you can see it. If you are low in norepinephrine, right? Or deficient, you may have depression. So in order for you to take the depression away, you may want to up the norepinephrine. How do we do that? By giving antidepressants that are specific in blocking the reuptake of norepinephrine, right? So then again, if you have wire from point A to point B and you have that bucket, you fill it with epinephrine or norepinephrine. What happens with that neurotransmitter is that after that signal goes through, this neurotransmitter gets reabsorbed back into the body. Okay, to put it simply. So what these medications do is it blocks that reuptake. So you take longer to take that neurotransmitter away, and therefore it remains there for longer, and therefore you're happier and less depressed, right? Because that's the whole point. Okay, moving on, we're gonna go to GABA, which is a mood regulator. It has an inhibitory action. Now, in this case, this one has an inhibitory action. I will block you, I will inhibit you from doing something. This stops neurons from becoming overexcited, right? We don't want them overexcited. We want them excited, but not overexcited. So this is, one that inhibits that overexcitation, right? This is why lower levels of GABA can cause anxiety, irritability, restlessness, because if you don't have GABA keeping you from becoming overexcited, you will become overexcited. Anxiety, irritability, restlessness, so on and so forth. However, in this case, we can use benzos or benzodiazepines. And these are drugs to treat anxiety, but they treat anxiety by increasing the action of GABA. And remember that GABA is the one that keeps you from being overexcited. So if I give you a medication that increases the action of the one guy that's going to keep you from being overexcited, then you're going to be cool, like a cucumber, right? You're going to be cool. You're not going to get overexcited. And that's why benzos have a calming effect, and they're used to treat anxiety attacks. Moving on, we're going to take a look at glutamate. Now, glutamate, unlike GABA, this is an excitatory amino acid, right? It's an excitatory neurotransmitter, and it can have major neurotoxic effects when it is way too high, right? This is a particular neurotransmitter that has been implicated with disease processes such as stroke, hypoglycemia, sustained hypoxia, ischemia, right? So a whole lot to do with hypooxygenation, to put it somehow. It is also has also been seen, so it's related to other disease processes such as Huntington and Alzheimer's. However, Alzheimer's is one of those that we have seen in just about every neurotransmitter that we have seen so far. So the one point that I want to see here is that in the case of glutamate, this glutamate is excitatory, can have neurotoxic problems, and it's usually related to those disease processes leading to or having something to do with hypooxygenation, such as a stroke or the state that you go in when you have hypoglycemia, sustained hypoxia, ischemia, so on and so forth. Those are hypooxygenated processes. And then we move on to serotonin. Serotonin is also an inhibitory neurotransmitter. Serotonin helps regulate mood, appetite, blood clotting, very important, sleep, and your circadian rhythm, right? When serotonin plays a role, let's just put it that way, it just plays a role when it comes to depression and anxiety, right? Now, medications known as selective serotonin reuptake inhibitors, or SSRIs, can relieve depression by increasing the serotonin level in the brain, right? So SSRIs will increase the serotonin level in your brain. Remember, that bucket gets filled up and electricity goes through better, right? More functional without being faulty, the transmission of that electricity. However, in the case of SNRIs, or the combination of serotonin and norepinephrine reuptake inhibitors, now we are increasing serotonin and norepinephrine, 2 instead of 1, right? And so people taking SNRIs, they take them to relieve the symptomatology of depression, anxiety, chronic pain, and fibromyalgia, right? So if you have concomitant processes other than depression, you may want to use an SNRI instead of an SSRI, right? Because there's 2 components to the SNRI, right? It'll hit on serotonin and norepinephrine versus the SSRI, which is only going to hit on serotonin. Does that make sense? So SNRI will have a wider, broader capability spectrum to work within certain processes. Okay, and so with that being said, this has been Neurotransmitters 0.001. I don't want to make it too long, and therefore this should be a bite-sized piece of information for you guys to munch on. Questions, concerns, feel free to hit that button and let me know what you need, and I'll do my utmost to get it in a easy, some sort of condensed way that can be delivered to you as fast as possible. All right, thank you guys, and you have a nice day. See you next time.